Space is the ultimate beautiful death trap. We are about to take a cosmic road trip to the 25 most terrifying destinations in existence. You will discover worlds where the very laws of physics break down and survival is not just difficult, it is utterly impossible. We will journey to the scorching edge of black holes and venture into the eternal frozen night of rogue planets. What strange force could rip a star apart from the inside? By the end of this, you will know the true extremes of our universe. What place do you think would be the most shocking to witness firsthand? Our journey begins much closer to home, with the very star that gives us life. The sun's golden face seems deceptively calm, but its outer atmosphere, a shimmering halo of plasma called the corona, is a realm of pure violence. This crown of superheated gas presents one of the most enduring mysteries in solar science. While the sun's visible surface simmers at around 5,500 degrees Celsius, the corona inexplicably heats up to millions of degrees. It is like walking away from a campfire and suddenly feeling a blast of heat more intense than the flames themselves. This unimaginable heat fuels the solar wind, a constant hurricane of charged particles racing outward in all directions. Occasionally, the sun's tangled magnetic fields snap, unleashing a coronal mass ejection. These are billion-ton clouds of plasma hurled into space at millions of kilometers per hour. Any spacecraft or asteroid caught in the direct path of such an event will be instantly sterilized, its very atoms torn apart. The danger is not just theoretical. From our safe distance of 93 million miles, we feel the corona's fury. A direct hit from a powerful solar storm could cripple satellites, knock out power grids across entire continents, and expose astronauts to lethal doses of radiation. This beautiful, shimmering crown serves as a constant reminder that our nearest star is not a gentle friend, but a titan capable of unleashing cosmic chaos. That same solar fury is a gentle breeze compared to the final, cataclysmic death scream of a star. We call this a supernova, and its aftermath carves a tombstone in space known as a supernova remnant. This is not a quiet graveyard, it is an expanding sphere of pure destruction, a shockwave traveling at tens of thousands of kilometers per second, faster than any sound could ever travel. This wall of energy slams into the surrounding interstellar gas, heating it to millions of degrees and shredding any matter in its path. If a planet were orbiting a neighboring star, this single wave would vaporize its atmosphere and scorch its surface down to the mantle. But the physical blast is only the beginning of the horror. The remnant unleashes a lethal cocktail of radiation, from the highest energy gamma rays to penetrating X-rays. This invisible onslaught would flood any nearby solar system, sterilizing worlds and scrambling the complex chemistry of life for light years in every direction. A prime example of this enduring chaos is the Crab Nebula. At its heart lies the crushed core of the original star, a pulsar spinning 30 times every second. This city-sized cinder is a powerful dynamo, blasting out beams of radiation like a relentless cosmic lighthouse. To be within its reach is to be subjected to a continuous, sterilizing bath. A supernova remnant is a stark reminder that the universe is not just vast, but violently active. Being anywhere near such an event is one of the most definitive, inescapable ways to be erased from existence. From this cosmic graveyard, we journey to a place where matter itself surrenders to an impossible density. The surface of a neutron star is a realm of such extremes that it defies all human intuition. Picture a star more massive than our sun, crushed into a sphere no wider than a city. This compression creates the most solid material in the known universe. A single teaspoon of it, brought to Earth, would weigh billions of tons, a mass so immense it would instantly punch through the planet's crust like a ghost through a wall. This impossible weight is a product of gravity so ferocious that it overwhelms every force that gives atoms their structure. Protons and electrons are forced together, merging into a solid, dense sea of neutrons. The very fabric of space-time is warped into a deep, smooth curve. Standing on this surface is an unthinkable prospect. You will be flattened into a film just one atom thick, your molecules instantly becoming part of that neutron ocean. But the horror does not end with the crushing gravity. The magnetic fields surrounding a neutron star are trillions of times more powerful than Earth's. From thousands of kilometers away, this field would wrench the iron from your blood and tear apart every complex molecule in your body. This magnetic fury is unleashed violently during starquakes. The star's solid crust, under unimaginable strain, occasionally fractures and shifts in events astronomers call glitches. These cosmic tremors release more energy than our sun emits in centuries, all focused into devastating bursts of X-rays and gamma rays. A neutron star is not just a dead sun, it is a furious, spinning diamond of pure destruction. That crushing gravity on a neutron star is just a prelude to the ultimate cosmic trap. A black hole's event horizon represents a boundary so absolute that nothing, not even light, can ever return. This is the point of no return, a one-way exit from our universe. The physics here are merciless. To escape its pull, you would need to travel faster than light itself, a feat the laws of physics forbid. Crossing this invisible threshold is a descent into a reality warped beyond recognition. The first thing you would experience is a gruesome process called spaghettification. The gravitational pull on your feet, being closer to the black hole's center, would be unimaginably stronger than the pull on your head. This difference in force would stretch your body into a long, thin stream of atoms, transforming you into a human noodle before utterly disassembling you into a flow of elementary particles. But the true strangeness is not just in the tearing apart, it is in the perception of time. If a friend were watching you fall from a safe distance, they would witness something bizarre. As you approach the event horizon, you would appear to slow down, eventually freezing completely, a ghostly image silhouetted against the blackness for the rest of time. From your own perspective, however, you would cross that boundary in a finite moment, witnessing the universe behind you speed up in a frantic blur of light as you are drawn inward. At the heart of our own Milky Way galaxy, a supermassive black hole named Sagittarius, a star, patiently waits. With a mass 4 million times that of our sun, its event horizon is a gaping maw, a silent predator lurking in the galactic core. It serves as a constant, humbling reminder that some places in the cosmos are not just dangerous, they are final. Just outside that final boundary of the event horizon lies a storm of pure light and fury. The accretion disk of a black hole is a swirling maelstrom of doomed matter, a cosmic carousel spinning at nearly the speed of light. This is not a gentle glide into oblivion. Vast streams of gas, dust, and even entire stars stripped apart by tidal forces are caught in this frantic orbital dance. The friction within this churning soup of particles is unimaginable, heating the material to temperatures of millions of degrees. This incandescent hell glows not with visible light, but with an intense blaze of X-rays, a screaming beacon announcing the violence of its own destruction. If you could see it with human eyes, it would be a brilliant twisting pinwheel of light, far brighter than an entire galaxy of stars. Films like Interstellar gave us a stunning, though sanitized, visualization of this luminous disk, warping the light around it into a shimmering halo. The reality is infinitely more chaotic. This region is a relentless blender of high-energy particles and lethal radiation, where magnetic fields snap and twist, launching jets of superheated plasma thousands of light years into space. It is the brightest and most violent environment known to exist, a paradoxical ring of fire that marks the doorstep of absolute nothingness. The brilliant light of a black hole's accretion disk is just one small part of the galaxy's most chaotic neighborhood. The center of our own Milky Way is a cosmic metropolis of unimaginable scale and violence. Here, millions of stars are crammed into a relatively tiny space, all orbiting the supermassive black hole, Sagittarius, a star. If our solar system were located in this core, our night sky would not be a dark canvas with pinpricks of light. It would be a perpetual blazing daylight, lit by a swarm of stars so close they would appear larger than our own moon. This stellar density creates a perpetual dance of danger. The gravitational pull from so many massive bodies constantly tugs and jostles the stars, making stellar collisions a real possibility. A close gravitational encounter, a near miss between two stars, would be enough to catastrophically disrupt entire solar systems. Planets could be ripped from their stable orbits and sent careening into the cold void of interstellar space, or worse, flung on a death spiral directly into the waiting maw of the central black hole. Beyond this gravitational chaos, the very space between the stars is poison. The Galactic Center is filled with young, massive stars that live fast and die young. bathing the region in intense ultraviolet radiation. This is combined with the lingering death cries from supernova remnants and the constant high-energy X-ray hum from neutron stars and stellar mass black holes. The ambient radiation level is so high it would strip away planetary atmospheres and break down the complex molecules essential for life. This place is not dangerous for one single reason, but for a terrifying combination of them all. It is a gravitational mosh pit set within a permanent, sterilizing radiation storm. That chaotic, radiation-drenched core is the polar opposite of our next destination, a place defined by its profound and absolute emptiness. We are leaving the crowded Galactic Center for the endless, dark voids between the stars. Here, worlds drift alone, untethered from any sun. These are rogue planets, and their existence is a special kind of cosmic terror. Ejected from their home solar systems by gravitational encounters, they are now permanent exiles, sailing through the interstellar blackness. The surface of such a world is a monument to cold. With no star to warm it, temperatures plummet towards absolute zero, the point where all molecular motion theoretically stops. An atmosphere would be impossible here. Any gases from nitrogen to oxygen would freeze solid, falling to the ground as a blanket of snow that will never melt. The landscape would be a perpetual ice field under an eternal starry night, with no sunrise ever to break the darkness. The only light would come from the faint, distant glow of the galaxy, casting weak, haunting shadows. It is a deep freeze beyond any earthly comprehension. Yet beneath this frozen crust, a sliver of a possibility might exist. The residual heat from the planet's formation, or the radioactive decay in its core, could maintain a vast global ocean of liquid water trapped under miles of ice. This seems like a potential refuge, but it is a prison. The pressure at the bottom of this sunless sea will be crushing, thousands of times greater than the deepest part of our own ocean. And without a sun's energy, the chemistry for life as we know it could never begin. There is no weather, no seasons, no day, no year. The only change is a slow, inevitable cooling over billions of years as the planet's internal heat slowly bleeds away into space. The true horror of a rogue planet is not a violent death, but an eternal, silent, and sunless solitude. That profound emptiness is shattered by the existence of true stellar titans, cosmic behemoths whose very nature is volatility. Vii Canis Majoris is not merely a star, it is a leviathan. If placed at the center of our own solar system, its searing surface would extend beyond the orbit of Jupiter, engulfing all the inner planets in a fiery embrace. This hypergiant is thousands of times larger than our Sun, a scale so vast it defies simple comprehension. Such immensity comes at a terrible cost. These stars are cosmic spendthrifts, burning through their colossal reserves of nuclear fuel in a frantic blaze lasting only a few million years, a mere heartbeat in the lifetime of a star like our Sun. They live fast and die young, and their entire existence is a prolonged, violent eruption. The star's gravity struggles to hold onto its own outer layers against the titanic pressure of radiation from within. The result is a stellar wind of unimaginable ferocity, a continuous hurricane blowing the star itself into space. Each year, Vii Canis Majoris ejects a mass equivalent to the entire planet Jupiter, casting off its own body in a vast, turbulent shell of gas and dust. This expanding nebula of death, forged from the star's own flesh, glows with the energy of its destruction. Any hypothetical world orbiting this monster will be scoured clean, its atmosphere stripped away by this relentless gale and its surface bathed in intense, sterilizing ultraviolet light. The entire system is built on a foundation that is already crumbling, a kingdom living on borrowed time before its ruler's inevitable, catastrophic demise. The supernova that awaits will be one of the most powerful events in the galaxy, a final, defiant explosion that will briefly outshine entire galaxies. To witness such a star up close is to stand in the shadow of a time bomb that has already begun to tick. The fury of even the largest stars is utterly dwarfed by the engine at the heart of an active galactic nucleus, a cosmic monster we call a quasar. Imagine the power of 1,000 galaxies, all the hundreds of billions of stars within them, compressed into a single brilliant point of light no larger than our solar system. This is the terrifying reality of a quasar. Its staggering energy comes from a supermassive black hole, but not a quiet one like Sagittarius, a star at our galaxy's center. This black hole is a glutton, actively feasting on an entire whirlpool of gas, dust, and stars from a surrounding accretion disk. The friction within this doomed matter heats it to such an extreme that it glows with a light that can be seen across the universe, a beacon of pure consumption. This single core can outshine every star in its host galaxy combined, making it the most luminous object in existence, but the light is only a side effect of the true violence. As matter spirals inward, some of it is caught by the black hole's immensely powerful magnetic fields and focused into two narrow beams or jets, shooting out from its poles at nearly the speed of light. These relativistic jets are sides of pure energy, stretching for millions of light years into intergalactic space. Any galaxy, any star system, any world unfortunate enough to lie in the direct path of one of these jets will be subjected to an unimaginable radiation storm. It would be scoured clean, its atmosphere vaporized, its surface melted, and any potential for life utterly erased. These jets are so powerful they can influence the formation of stars in entire galaxy clusters, shaping the evolution of the cosmos itself from an unimaginable distance. To witness a quasar up close is to stare into the heart of a cosmic dragon, a force of nature that doesn't just destroy worlds, but dictates the fate of galaxies. The magnetic violence of a magnetar redefines the very meaning of the word power. These are a special, terrifying class of neutron stars, but with a singular, horrifying difference. A magnetar possesses a magnetic field so strong it defies all reason, a force a quadrillion times more powerful than the field that protects our own planet. This is not just a stronger magnet, it is a fundamental rewriting of the laws of physics within its domain. At a distance of 1,000 kilometers, this field would not just pull on the iron in your blood. It would do something far more sinister. The magnetic force would be so intense it could actually distort the electron clouds surrounding every single atom in your body. This warping effect would make the chemistry of life, the very bonds that hold molecules together, utterly impossible. Your body would simply cease to function on a subatomic level long before you were physically torn apart. This unimaginable tension is locked within a solid crust of neutron star material, a surface under unbearable strain. Occasionally, this crust can no longer hold, and it fractures. This is a starquake. It is not like an earthquake on Earth shifting tectonic plates. This is the entire solid surface of a city-sized star with the mass of a sun suddenly cracking and shifting. The energy released in that single cosmic shudder is beyond comprehension. In a fraction of a second, a magnetar can unleash more energy than our sun will emit over 100,000 years. This energy erupts as a blistering flash of gamma rays and X-rays, a death ray burst that can travel across the galaxy. We know this is not just theory. In December of 2004, a magnetar 50,000 light years away, halfway across the Milky Way, experienced a starquake. The radiation pulse that reached Earth was so powerful that for a brief instant, it actually compressed our planet's protective magnetic field. It ionized the upper atmosphere, and for 5 seconds, this single star outshone the full moon in gamma rays. This was an event from an unimaginable distance, a cosmic shout that still managed to physically shake our planet's shield. To be within even a few light years of such an eruption would be to experience a sterilizing blast that would wipe the surface of any world clean. A magnetar is a cosmic weapon that fires at random, a reminder that some of the universe's greatest dangers are not just places, but events waiting to happen. While a magnetar's fury is a distant, theoretical danger, a true hellscape awaits right next door. Venus is often called Earth's sister planet, a name that could not be more misleading. This is not a welcoming world, but a brutal warning of how a planet can turn against itself. The danger here is not from a collapsing star or a voracious black hole, but from a climate gone mad. A runaway greenhouse effect has turned Venus into a pressure cooker. The atmosphere is so thick and heavy that the pressure at the surface is 92 times greater than what we experience on Earth. It is the same crushing weight you would feel if you were submerged under nearly 1 kilometer of ocean water. Every square inch of your body would be subjected to this immense, relentless force. Yet the pressure is only the first layer of the nightmare. The same blanket of carbon dioxide that creates this crushing pressure also traps solar heat with terrifying efficiency. The surface temperature is a constant 465 degrees Celsius, hot enough to melt lead. Spacecraft that have landed there did not last long, their metal skins slowly softening and succumbing to the inferno before they fell silent. And then there are the clouds. They are not made of water vapor, but of corrosive sulfuric acid. This toxic fog shrouds the entire planet, creating a perpetual gloomy twilight. It even rains this burning acid, but the droplets never reach the ground. The intense heat at the lower altitudes causes them to evaporate, rising back up to condense and begin the cycle again. Venus is a planet trapped in a self-made oven, a stark and sobering example of how a world with initial conditions similar to our own can transform into an absolute hell. It proves that cosmic danger does not always lurk in the depths of space. Sometimes it is a path a planet can take, a terrifying reminder written in acid and fire right in our own celestial neighborhood. The violent creation of worlds is not a gentle process. Before a solar system settles into stable orbits, it endures a period of pure chaos within a protoplanetary disk. This vast spinning platter of gas and dust swirling around a newborn star is a cosmic construction site of unimaginable violence. Here, countless chunks of rock and ice, called planetesimals, are constantly colliding. They do not merely bump into each other, they smash together with cataclysmic force, their impacts releasing enough energy to melt rock and vaporize metal. It is a continuous, deafening bombardment, a celestial demolition derby where the only way to grow is to consume others. Out of this relentless carnage, the planets themselves are slowly, painfully assembled. But the danger is not just from the chaotic collisions. The fledgling star at the center is a tempestuous child, unleashing fierce blasts of ultraviolet radiation. This intense light acts like a cosmic blowtorch, striking the gas in the disk and stripping it away in a process called photoevaporation. For any young world attempting to form an atmosphere, this is a constant losing battle. The very air it tries to hold onto is being blasted back into space by the star's furious breath. This disk is a place of creative destruction, a beautiful and terrifying nursery where the peaceful planets we know are forged in a crucible of fire and relentless impacts. What chance would a fledgling world have in such a brutal environment? Our own planet is wrapped in a protective shield, but that shield itself is a zone of lethal radiation. The Van Allen belts are too vast, donut-shaped regions of space where Earth's magnetic field has trapped a swirling soup of high-energy charged particles. This invisible fortress deflects the worst of the solar wind, protecting life on the surface from constant bombardment. Step inside the belts themselves, however, and you enter a different reality. Here, protons and electrons, captured from the sun and deep space, spiral along magnetic field lines at nearly the speed of light. For any unprotected human, a prolonged stay here will be a death sentence, as this intense radiation shreds DNA and destroys cellular function. The danger is not just biological. For the delicate electronics of satellites and spacecraft, this environment is a minefield. A single high-energy particle can cause a computer to glitch, erase memory, or suffer permanent damage. This presented a very concrete problem for the Apollo missions heading to the moon. To reach lunar orbit, the spacecraft had to pass directly through the most intense part of the inner Van Allen belt. Mission planners had to chart a precise high-speed trajectory, essentially a narrow corridor that minimized the astronauts' exposure time. They also timed the launches to avoid periods of heightened solar activity, which could make the belts swell with even more particles. Even with these precautions and the ship's aluminum hull acting as a shield, the crew received a measurable, though acceptable, dose of radiation. The Van Allen belts serve as a critical reminder. The void of space is never truly empty, and even the mechanisms that keep us safe can create pockets of extreme danger just beyond our atmosphere. Lurking in the cosmic shadows between stars and planets is a ghost, a celestial failure known as a brown dwarf. These objects are born from collapsing clouds of gas, just like true stars, but they simply lack the mass to ignite the sustained nuclear fusion that makes a star shine. They are too massive to be considered planets, yet not massive enough to become the suns of their own systems. Instead, they exist in a state of perpetual twilight, glowing faintly with the residual heat of their violent birth. This warmth slowly fades over billions of years as they cool into near total blackness. Imagine an atmosphere more turbulent than Jupiter's greatest storm, but locked in a deep freeze. The weather on a brown dwarf is a nightmare of exotic elements. Temperatures can allow for clouds not of water, but of molten iron and silicate minerals, the very stuff of rock. This means it could literally rain liquid metal and hot sand, driven by winds that scream at hurricane forces across a perpetual dark sky. For any moon or planetesimal unfortunate enough to be orbiting this failed star, existence would be a special kind of hell. There would be no sunrise, no golden light to fuel photosynthesis or warm the ground. The primary source of energy would be a dull infrared glow from the brown dwarf itself, a dim burgundy light that provides little more than a perpetual, gloomy twilight. This world would be a cold, dark, and gravitationally unstable place, forever circling a fading ember in the void. That fading ember of a brown dwarf offers a cold and quiet death, but some stellar corpses refuse to go quietly into the night. A pulsar wind nebula is the aftermath of a supernova, where the central engine is a furious, spinning dynamo. This is the domain of a pulsar, a rapidly rotating neutron star that sweeps the cosmos with lighthouse beams of radiation. But its true power is not just in those beams, it is in the relentless hurricane it unleashes into space. The pulsar's intense magnetic field and rapid spin act like a colossal generator, pulling charged particles from its surface and accelerating them to nearly the speed of light. This creates a pulsar wind, a supersonic gale of electrons and protons that screams outward in all directions. This wind does not travel peacefully into the void. It slams at full force into the slower-moving debris of the supernova remnant that birthed it. The collision creates a massive shockwave, a standing wall of energy where particles are caught, whirled in a magnetic maelstrom, and accelerated even further. As these ultra-relativistic particles are forced to spiral along the magnetic field lines, they release their immense energy as synchrotron radiation, a brilliant and deadly light that blazes across the entire electromagnetic spectrum, from radio waves to gamma rays. The entire system glows not from starlight, but from this violent, continuous particle acceleration. The Crab Nebula provides the ultimate example of this cosmic engine. At its heart, a pulsar spins 30 times every second, and its powerful wind fills the entire nebula, illuminating its delicate, filamentary structure. Every shimmer of light you see in images of the crab, every intricate tendril of gas is powered by this one relentless particle storm. To venture inside a pulsar wind nebula would be to enter a continuous particle accelerator. The radiation levels are so intense they would instantly penetrate any known shielding, destroying electronics and scrambling the DNA of any living thing. It is a beautiful, luminous cloud that is in reality an expanding bubble of pure, sterilizing fury, a testament to a star whose death created something even more violently alive. Even the particle storms of a pulsar wind nebula cannot match the visceral geological fury of our next destination. We are traveling to Io, a moon of Jupiter, and the most volcanically active body in our entire solar system. Its surface is a canvas of pure chaos, painted in garish yellows, oranges, and reds by vast deposits of sulfur and frozen sulfur dioxide. This is not a world with the occasional volcano. This is a world that is a volcano. Hundreds of active vents constantly erupt, spewing fountains of molten rock and incandescent gas hundreds of kilometers into the black sky. Some of these plumes are so powerful they blast material clear off the moon, feeding a tenuous, toxic torus of gas that follows Io in its orbit around Jupiter. The landscape is a constantly shifting patchwork of lava lakes larger than entire cities and rivers of molten silicate rock. This relentless volcanism completely resurfaces the moon every few million years, erasing any craters and leaving behind a fresh, burning crust. So what powers this global, unending inferno? The answer lies not within Io itself, but in the colossal gravity of its parent planet, Jupiter. Io is locked in a constant gravitational tug-of-war. Jupiter's immense pull squeezes and stretches the moon's rocky interior. This process, called tidal heating, generates immense friction deep inside Io, melting its mantle into a global ocean of magma. This subsurface ocean constantly seeks a way to release its pent-up energy, bursting through the thin, brittle crust in a continuous, planet-wide eruption. The result is a world where the very ground beneath your feet is unstable and treacherous. The thin atmosphere, composed almost entirely of sulfur dioxide, is unbreathable and corrosive. The surface is coated in colorful but poisonous frosts of sulfur compounds, and the constant tremors from the eruptions would make standing upright a monumental challenge. Io is a stunning, violent demonstration of celestial mechanics in action, a world literally being torn apart and remade before our eyes by the invisible hand of a giant. The relentless geological fury of Io is a local event, a contained inferno, but the universe can orchestrate destruction on an infinitely grander scale, where entire galaxies become the players in a slow-motion catastrophe. This is the reality of a galactic collision, a billion-year-long dance of destruction. Picture the future of our own Milky Way, destined to merge with the colossal Andromeda Galaxy in about 4.5 billion years. From a distant vantage point, this cosmic ballet would look beautiful, a silent, swirling pastiche of starlight, but from within, it would be a period of unimaginable chaos. The first and most pervasive threat is gravitational anarchy. The combined gravitational pull of two intermingling galaxies creates a wildly unstable environment. Stars are no longer held in neat circular orbits. They are violently slung around like marbles in a spinning jar. Many will be flung clear out of the galaxy entirely, condemned to a lonely eternity in the intergalactic void. Others will be thrown onto new, perilous paths, sent careening directly through the crowded galactic core or on a collision course with other stars. While direct star-on-star impacts are still statistically rare due to the vast emptiness of space, close gravitational encounters would be common and utterly devastating. A star passing even remotely close to our solar system would have a catastrophic gravitational pull, yanking planets from their stable orbits and sending them spiraling into the cold or plunging them into their own sun. The serene order of a solar system will be shattered in a single gravitational flyby, but the real violence is reserved for the galaxy's gas and dust. These immense clouds, the raw material for new stars, do not pass to each other peacefully. They slam together. This colossal compression triggers a ferocious firestorm of starbirth, a stellar baby boom of epic proportions. Thousands of new stars ignite at once, but this is no gentle creation. These are massive blue-white stars that burn brilliantly and die young. Their short, violent lives end in a rapid succession of supernova, bathing the entire galactic environment in relentless waves of high-energy radiation. The space between stars will become a permanent radiation storm, stripping away planetary atmospheres and sterilizing worlds on a galactic scale. For millions of years, the merged galaxy will be a beautiful, luminous, and profoundly dangerous place, a crucible where solar systems are born and destroyed in the same fiery embrace. That slow-motion galactic collision would unfold over eons, but on a single world named WASP-76b, a daily apocalypse is already underway. This is a hot Jupiter, a gas giant orbiting so close to its star that a single year lasts less than 2 Earth days. But WASP-76b has a far more terrifying distinction. It is tidally locked, meaning one side of the planet is in permanent, scorching daylight, while the other is trapped in an eternal, frigid night. This fixed orientation creates a hellscape beyond any earthly comparison. On the day side, the relentless stellar radiation heats the atmosphere to a temperature of nearly 2,400 degrees Celsius. This is so hot that metals like iron, which on Earth are solid and strong, are completely vaporized. The very molecules that form rocks and metals on our world are torn apart into a gaseous haze, creating an atmosphere of vaporized stone and iron. Then the planet's global weather system takes over. Ultra-fast winds, screaming at thousands of kilometers per hour, sweep across the tortured world. These hurricanes carry the vaporized iron from the incandescent day side over the terminator line, the boundary between light and dark. As this metallic gas crosses into the perpetual shadow of the night side, the temperature plummets by nearly 1,000 degrees. Here, the iron vapor can no longer remain a gas. It condenses, forming droplets of liquid metal in the upper atmosphere, and then it falls. The night side of WASP-76b is subjected to a perpetual burning rain of molten iron. This is weather forged in a stellar furnace, a cycle of vaporization and condensation that turns the very elements of a planet into a weapon. There is no solid surface to stand on, only a deep, turbulent atmosphere where a creature will be simultaneously incinerated, asphyxiated, and then pelted by droplets of liquid metal. This exoplanet is a stark laboratory, showing us just how alien and violently beautiful planetary systems can become. Beyond the last planet's orbit and far past the scattered disk of the Kuiper belt lies a realm of pure shadow. The Oort cloud is a vast spherical shell of frozen debris surrounding our entire solar system, a ghostly frontier stretching nearly halfway to the next star. This is the ultimate deep freeze, where temperatures hover just a few degrees above absolute zero, the theoretical point where all motion ceases. Trillions of icy bodies, some as large as mountains, drift in this profound and perpetual darkness, mere fossils from the solar system's violent birth. The cloud itself is not the danger, it is a silent frozen reservoir. The true threat lies in its profound gravitational instability. Our sun's hold on these distant objects is tenuous at best, a whisper of gravity across the void. When another star passes even remotely nearby on its own galactic journey, its gravity acts like a subtle nudge in the cosmic dark. This stellar flyby, an event that happens every few 100,000 years, perturbs the delicate orbits of these dormant icy planetesimals. Some are flung out into interstellar space forever, but others are sent tumbling inward toward the heart of our solar system. Over thousands of years, these icy wanderers accelerate, falling sunward to become the long-period comets that streak through our inner skies. Their beautiful glowing tails are a spectacular warning. Each one is a potential impactor, a frozen relic from the outer dark that has been gravitationally redirected on a new, deadly trajectory. The Oort cloud serves as a chilling reminder that our peaceful corner of the cosmos is not an isolated fortress. We are surrounded by a distant, icy moat, and the occasional ripple from the wider galaxy can send its guardians falling inward, turning silent sentinels into potential missiles aimed directly at our world. The silent, icy sentinels of the Oort cloud offer a potential for slow, cold impact, but the universe holds a weapon far more swift and decisive. A gamma-ray burst is the single most powerful explosion known to exist, a flash of light that can briefly outshine every star in 1,000 galaxies combined. These events are the death cries of the most massive stars, or the catastrophic mergers of neutron stars. In their final moments, they do not die with a symmetrical bang, but with a focused scream. The catastrophic collapse unleashes twin jets of radiation, narrow beams of pure energy that blast outward from the poles of the dying system at over 99.9% of the speed of light. All of that unimaginable power, equivalent to the energy our sun will release over its entire 10 billion year lifetime, is concentrated into these two sides that slice through the cosmos. The danger is not in a general explosion, but in this precise, focused aim. If a gamma-ray burst were to occur anywhere within a few thousand light years of Earth, and if one of those beams were pointed directly at us, the consequences would be apocalyptic. The first wave, a blast of gamma rays and X-rays, would strike our atmosphere like a cosmic tsunami. It would not just warm the planet, it would chemically rip it apart. The intense radiation would break apart the molecules of our protective ozone layer, shredding it and leaving the surface exposed to the full, lethal fury of the sun's ultraviolet light. The sky itself would glow with a poisonous nitrogen oxide smog. Every living thing on the sunlit side of the planet would be subjected to an instant radiation dose strong enough to cause severe cellular damage, a sterilizing flash that would trigger a global mass extinction event. The afterglow would be a protracted death, as the loss of the ozone layer would allow solar radiation to scour the planet for years, collapsing food chains and altering the climate irrevocably. We are fortunate that such events are rare in our galactic neighborhood, and that the beams are so narrowly focused, but their existence is a humbling reminder. A single star, dying in the right way and in the right direction, possesses the power to sterilize an entire spiral arm of a galaxy from an unimaginable distance. Beneath its banded, swirling face lies a world of escalating violence with no bottom. Jupiter is a gas giant, but that term is deceptively gentle. There is no solid ground to land on, no continental shelf to mark a safe depth. A descent into its atmosphere is a one-way journey into a pressure cooker the size of a planet. The beautiful cloud tops, which from a distance appear serene, are just the entrance to a maelstrom. As you plunge deeper, the weight of the atmosphere above you grows exponentially. The clear, cold hydrogen and helium gas quickly thickens into a corrosive soup of ammonia and ammonium hydrosulfide clouds, lashed by winds that never cease. Long before you could reach any kind of surface, the pressure would become insurmountable. It would compact the gas around you until it behaved like a hot liquid, crushing any probe or vessel with the force of thousands of Earth atmospheres. The temperatures here would soar to thousands of degrees, hot enough to melt and then vaporize titanium. This is a realm where matter itself is forced into strange new forms. Deep within Jupiter, the pressure becomes so astronomical that it squeezes the very electrons from their orbits around hydrogen atoms. The hydrogen, the simplest and most common element in the universe, is transformed into a bizarre liquid metal. This swirling, electrified ocean of metallic hydrogen is a conductor more efficient than any copper wire on Earth. It is this churning, molten metal deep inside the planet that generates Jupiter's immense magnetic field, a protective shield so vast it could encompass the sun itself, and so powerful it traps lethal radiation in belts far more intense than our own Van Allen belts. This internal dynamo is so potent that Jupiter actually emits more heat than it receives from the distant sun, glowing with the fierce energy of its own violent birth and continuous gravitational contraction. The planet is quite literally cooking itself from the inside out. All of this internal fury manifests on the outside in storms of a scale we can barely comprehend. The Great Red Spot is the most famous, a colossal anticyclone, wider than our entire planet. It is not a temporary weather pattern, but a hurricane that has raged for at least 400 years. Its winds scream at over 400 miles per hour, swirling clouds of phosphorus and sulfur compounds in a perpetual, beautiful and terrifying vortex. This spot is merely the most visible symptom of a global system in constant, violent upheaval, where jet streams of gas race in opposite directions, creating turbulence that would shred any structure into atoms. To venture into Jupiter is to dive into an abyss where the very concepts of up and down lose their meaning, a world that is all atmosphere and no escape. This invisible web of dark matter is the true master of the galactic domain. While the planets, stars, and brilliant nebulae we see are the glittering ornaments, the dark matter halo is the immense unseen tree upon which they are all hung. Its danger is not one of fiery annihilation or crushing pressure, but of absolute gravitational control. This mysterious substance does not emit, absorb, or reflect any form of light, making it completely invisible to our telescopes. We only know it is there by its ghostly gravitational hand, a hand strong enough to grip entire galaxies and dictate their very motion. Without this massive, unseen halo providing extra gravity, a galaxy like our Milky Way would simply fly apart. The stars on its outer edges orbit far too quickly for the gravitational pull of the visible matter alone to hold them. It is as if the dark matter provides an invisible skeletal structure, a framework of immense mass that the luminous galaxy is built upon and trapped within. This control extends to the largest structures in the universe. Vast clusters containing thousands of galaxies are held together by the gravitational glue of their collective dark matter halos, which can contain over 10 times the mass of all the visible stars and gas combined. The entire visible universe is, in essence, a shimmering froth atop a deep, dark ocean of something we cannot see or touch, but whose gravitational will is absolute. To be inside a galaxy is to be a passenger on a ship you cannot see, steered by a captain whose nature is one of the greatest unsolved mysteries in physics. What would happen if this invisible scaffold were to suddenly vanish? The beautiful, ordered spiral of a galaxy would instantly unravel, its stars flung in all directions into the endless void. Our cosmic home is a beautiful prison, and the dark matter halo is its unseen, impenetrable wall. This perversion of chemistry finds its ultimate expression on a carbon planet, a world forged not from rock and iron, but from soot and tar. Here, the very elements of life are twisted into a toxic nightmare. The planet's interior will be a geologist's dark fantasy. With carbon far more abundant than oxygen, the planet's core would not be molten iron, but a crystalline lattice of pure carbon, a diamond of unimaginable size. Yet this glittering heart beats within a world whose surface is the antithesis of a jewel. The landscape would be a sticky, black expanse of hydrocarbons, a global oil slick of tar and bitumen. The atmosphere offers no relief, a thick, poisonous haze of carbon monoxide and methane, completely unbreathable and choking out any view of the stars. And then there is the weather. If temperatures were just right, the skies would not rain water, but a corrosive downpour of raw gasoline or thick, sticky hydrocarbons. Imagine standing on a vast black plain under a smog-choked orange sky as a storm begins to pour flammable, toxic liquid from the clouds. Every single condition on this world is a direct inversion of what life requires. Where we need water, it offers poison. Where we need a clear atmosphere, it provides a suffocating blanket. This is a planet where the fundamental building blocks of biology have been corrupted into a global death trap, a stark reminder that the same cosmic ingredients that can create a world like Earth can also create its perfect, horrifying opposite. The universe is not just a collection of dangers, but also of profound absences. After journeying through violent stars and crushing gravity, we now face a terror of a different kind, the horror of nothingness itself. This is the Boötes Void, a region of space so empty it defies comprehension. Stretching for hundreds of millions of light years, this cosmic desert is a staggering void where galaxies are almost non-existent. If you were to place our Milky Way at its center, the nearest major galaxy would be tens of millions of light years away in every direction. The night sky would not be a tapestry of stars, but a perfect, unbroken blackness, punctuated by only a handful of faint, lonely pinpricks of light. The true danger of the Boötes Void is not an active force that kills you, but a passive reality that sentences you to an inevitable end. There will be no stars to provide light or energy, no asteroids to mine for resources, no planets to offer even a barren foothold. Your ship would become a tiny, isolated tomb, drifting through an ocean of absolute nothing. Every passing moment would carry you further into the cold, with no destination in sight. The distances are so immense that even at the speed of light, a journey to the nearest cluster of galaxies would take longer than the current age of our planet. This is a death from cosmic isolation, a slow and silent end where the greatest monster is the sheer empty scale of the cosmos itself. Even the absolute void has a certain stark purity, but our final destination offers a more active and alien form of danger. We arrive at Neptune's captured moon Triton, a world of exquisite and paradoxical violence. This is one of the coldest places ever measured, with surface temperatures plunging to minus 235 degrees Celsius. At this profound chill, the very air we breathe would not be a gas, but a frozen solid. The landscape is a crust of nitrogen ice, a pale, brittle terrain that behaves like rock in this deep freeze. Yet this frozen world is far from dead. Triton is geologically active, punctuating its silent surface with explosive geysers. These are not fountains of water, but of nitrogen gas and dark, dusty material. The mechanism is a stunning example of alien physics. Scientists believe that the weak sunlight reaching Triton is enough to heat dark, solid nitrogen deposits just beneath the transparent surface ice. This solid nitrogen does not simply melt, it sublimates, transforming directly from a solid into a pressurized gas. Trapped under the ice, this gas builds up until the overlying crust can no longer contain it. The ice then ruptures and the pent-up nitrogen erupts in a violent plume, carrying dark dust from below high into the sky. These geyser plumes can soar several kilometers into Triton's incredibly thin atmosphere, a faint wisp of nitrogen and methane, before the dark material drifts back down to create vast, streaky deposits on the icy plains. The combination of factors here is what makes Triton so uniquely treacherous. Its gravity is incredibly weak, only about 8% of Earth's. This means the geyser plumes can rise to astonishing heights, and any material thrown upward takes a very long time to fall. The environment is a bizarre mix of extreme cold and explosive activity. You could be standing on a plane of frozen nitrogen that seems as solid as granite, only for it to suddenly fracture beneath your feet without warning, blasting you with a high-pressure jet of freezing gas and dark particulate. The energy for this activity is a mystery, likely driven by tidal heating from Neptune's immense gravitational pull, a final, faint warmth at the heart of an ice world. Triton is a beautiful, frozen clockwork toy, still ticking with a subtle and unpredictable violence, proving that even at the edge of the solar system, the universe has surprises in store. From the crushing heart of a neutron star to the silent, sunless eternity of a rogue planet, we have traveled across a cosmos that is both beautiful and terrifyingly hostile. These are not just distant curiosities, they are the fundamental forces that have forged the universe we see today. Supernova have scattered the very elements that form our world into the galactic winds, while the violent chaos of galactic collisions has given birth to new generations of stars. This relentless cycle of destruction and creation is what makes a safe harbor like Earth not just a happy accident, but a statistical miracle. Our planet is a tiny, fragile oasis in a desert of extremes, a precious refuge against the unimaginable forces that shape reality itself. Every one of these dangerous places teaches us something profound about the cosmos, and in doing so, teaches us to appreciate the delicate balance we call home. So tell me, which of these destinations left you the most awestruck or unsettled? Was it the liquid metal rain of WSP-76b, or the silent, ghostly grip of dark matter? Share your thoughts in the comments below, and if you enjoyed this journey to the edge of existence, subscribe for more explorations into the deepest mysteries of the universe.